What if you could build your own comfy UI nodes that work like CyberChef's recipe system? Today, I'll show you exactly how to do it.
comfyui is a node-based interface for building generative AI workflows. You connect components, define execution paths, and construct complex pipelines visually. CyberChef, on the other hand, is a browser-based tool for data transformation and analysis. It was created by the UK intelligence agency GCHQ for cybersecurity tasks like encoding, decoding, hashing, and parsing structured data chaining operations into structured recipes. Think of it as a playground for hackers, analysts, and anyone who loves clever data manipulation.
Now, here's the shift. I don't want you to think of comfyui as just an AI tool. I want you to see it as a workflow engine. Once you understand that, it stops being just stable diffusion nodes and starts becoming a modular system for building utilities, processors, and entire transformation pipelines. And that's where the real power is. So, here's the plan. We take a CyberChef recipe, turn it into a node, and embed that logic directly inside comfyui. We end up with a CyberChef-style node running inside our workflow. That's the goal.
All right, before we start, please note there are a few prerequisites. You should be comfortable with Linux the Penguino. Here, we use Arch Linux. You should know your way around Podman, Python, Git, and be able to read a Docker file and understand JavaScript. If you are new to any of that, don't worry. I'll walk through the commands, explain each step, and keep everything practical.
We will install Podman and its dependencies. Once installation completes, we verify it by checking the Podman version. If the version is displayed, Podman is correctly installed. Next, configure Podman for rootless operation. This involves 3 commands. 1. Enable user namespaces. 2. Configure subuid and subgid mappings. And 3. Enable lingering so containers keep running in the background.
Before we build anything, we need to set up a clean workspace. In my case, the workspace lives on an external drive mounted at Mount Storage BlazingLab. I strongly recommend using a high-capacity drive, for example, an 8 terabytes, non-volatile memory express. Models grow quickly, and you don't want to run out of space halfway through your experiments. For simplicity, clone the repository I prepared. It contains all the required files you can follow along without having to recreate the structure manually. Inside comfyui, make sure you set up the folders our container will mount later for models, custom nodes, input, and output.
Now we build the comfyui image. Thanks to our Docker file, when we run podman build command with the tag comfyui, it handles everything for us, cloning the comfyui repository, setting up Python, installing dependencies, and producing a ready-to-run image. Next, we run the script run-comfyui. This maps the internal container directories to our external workspace folders. Keep in mind, you will likely need to adapt the base directory variable to match your workspace path. In addition, if you do not have a NVIDIA GPU, remove the device option, make the script executable, then run it. To verify the installation, run podman process status and logs comfyui, or simply open it in your browser. If the interface loads, you're ready. As a bonus, there's a helper script reload to restart comfyui quickly. Pro tip: if you need to debug or inspect something manually, you can run podman execute with the iterative shell option to obtain an interactive shell inside the running container to explore the internal files directly.
Here is the fun part. Let's understand what constitutes a node in comfyui. A node is simply a Python class. You give it a name, for example, my custom node, and it defines the input types, the return types, the processing function, and the category where the node will be searchable within the node library. In our examples, will mostly work with strings for simplicity. If you want to experiment with other data types, you can refer to the official documentation. Also, keep in mind that all code uses the legacy version 1 for simplicity and compatibility with many existing nodes. There is a newer version 3 schema, and it introduces some structural changes. In v3 object-based input-output, execute method, and class-only entry point.
Before we dive into the steps required to register a node, let me walk you through the folder structure. Whenever you create a new library with one or multiple nodes, you create a folder inside the custom nodes directory and give it a name. In our case, it's called comfyui-cyberchef-nodes. Inside that folder, you'll have a nodes directory. This is where your node classes are defined. Optionally, you can also include a web folder. This is used for more advanced or interactive nodes that require front-end components. Finally, the init file is where we register and expose the nodes so they become available inside our workflow in comfyui. The requirements text file is used to specify additional Python libraries, for example, if a node needs cryptographic functionality or other external dependencies. Watch this. The class myCustomNode is defined inside a custom node Python file and then imported into the init file to make it available in the workflow.
Do not forget to restart comfyui for the backend code to take effect.
There you go. Our custom node available in comfyui.
We take a recipe to base64. We create a node file base64 nodes which define the node class CyberChef2 base64 that takes a string as input, defines an encode function that accepts a string, and returns the encoded text as a string. This node will appear under the category CyberChef encoding. Next, we have another node class from base64 that decodes the encoded text back into plain text. Once the node classes are defined, we import them into the init file and make sure we register the node classes inside node class mappings and define their display names inside node display name mappings in comfyui. Do not forget to add node class mappings and node display name mappings to the all list, which specifies which module symbols are intentionally exposed.
Again, do not forget to restart comfyui for the backend code to take effect.
There you go again. 2 functional nodes in our comfyui workflow.
Here's something I want to show you. On the right, we have a node without any JavaScript enhancing its front-end behavior. When I type an IP address and execute it, nothing appears unless I connect another node, like preview as text, to display the output. On the left, this node includes JavaScript code, extending its front-end capabilities. It functions as a standalone component, handling both input and output directly inside the node. No extra preview node needed. So what's happening behind the scenes? The Python node class returns UI text data. That data is then processed by the JavaScript file defang display inside the web folder. The JavaScript adds logic during node creation and displays output when the node executes.
And that clearly the difference between those two nodes, backend and front-end logic. I really hope you have a better appreciation for comfyui. Understanding nodes can be complex, but they're incredibly powerful, whether for real-time workflows, 3D modeling, cybersecurity, utilities, and much more. I hope you enjoyed this video as much as I enjoyed creating it. If you have questions or want to explore something further, please feel free to ask.